if we look at this formula, how many of these variables have we seen before? We have seen two. Well, really though, we've seen two of these three variables in other equations. We've seen energy in another equation, and we've seen time in another equation. Correct? Now, here's the cool thing. Okay? What does PE actually stand for? Big P, little e. PE stands for electrical power. And the formula reads that electrical power is equal to the amount of energy a machine transforms per second. Okay? Power is measured in watts. All right? And watts are going to become very important in the next little while because we're going to be talking about energy cost calculations. When your parents or guardians or whoever pays the bills at home get a power bill from Hydro-Quebec, they actually have to pay for every kilowatt hour that they use. Okay? So turning off lights, using more energy efficient light bulbs, turning the heat down in the house at night when everybody's sleeping, these are all ways to lower the amount of power that our house uses. Okay? Now, when we talk about power, we're actually looking at different appliances and we're saying, okay, how much energy does this machine take in and transform into something else, into another kind of energy? So what ends up happening when I flick the light switch here, okay, the light switch is closed, well, it's open right now, meaning that the circuit is broken. When I close the switch, okay, the lights come on, and the electrical energy is being transformed into what kind of energy? Radiant energy. Okay? So when you want to actually calculate how much power an appliance is using, what you're really looking at here is you're looking at the amount of energy that's getting transformed into something else. Okay? Power is doing work. And the work that my kettle does over here is that it takes electrical energy from the wall and it transforms it mostly into thermal energy because it boils the water inside. There's a coil inside my kettle that gets surrounded by water, and because it heats up, the water heats up. And then I make my cup of tea, right? Okay, so when we look at this formula, all right, this formula is telling us that the electrical power of an appliance is nothing more than the amount of energy that it's able to transform in a second or in a unit of time. Now, in this case, time is going to be measured in what? Time. Seconds. And in this case, energy is measured in joules. So its power is joules per second, and a joule per second is equal to a watt. Okay? That's one power formula. Luckily for us, we have another way of calculating electrical power, or the power of an electrical device. And that's the one that we actually used on our most recent lab. Electrical power is also equal to the potential difference of a situation multiplied by the current intensity. Now, we know that power is equal to joules per second. But wait a minute. There's no joules and there's no seconds in V and I. How can we use the exact same formula, or two different formulas to give us the exact same answer. The question was, how is it that these two vastly different formulas can actually both give you electrical power? Because E and T is not the same thing as V and I. Well, it can be the same thing. Okay, and here's what I'm going to prove to you. If we look at V, okay, what does V stand for? Volts or potential difference. What is that original formula for potential difference? Potential difference is V is equal to E over Q. Okay. What is the original formula for current intensity? I is equal to Q over T. I see some similarities. Okay, I see that elusive E that I'm looking for, and I see that elusive T that I'm looking for. So if the question was, how does this formula here equal this formula here? Well, let's sub in some values here that we know. We know that PE is equal to V times I. But what is V also equal to? V can be replaced by E over Q, can it not?
Yes.
Okay, so if I say this, E over Q, now what can I replace I with?
Q over T.
Q over delta T. Now if I'm multiplying these two things, if I'm multiplying E over Q by Q over T, is there something that can cancel out there?
Yes.
What? See you later, Q's. It's been nice. That gives us our E over delta T. This is why these two formulas can be used interchangeably. So if you have a word problem that says that you only have potential difference or that you have current intensity, okay, you can use that to solve power just like if you were given energy over a unit of time. What would you do if you were given time in minutes? Could you just plug in the minutes? What would you have to do? You would have to convert that to seconds, correct? Okay. Do these two formulas make sense to you now? Now, do we remember what the purpose of power is? Okay, so we have to remember that electrical power, the concept of power is the ability of something to do work. And when you use an appliance or a machine, okay, that uses electrical energy to create something, create a different form of energy, it's doing work for you. All right, take that hand mixer for an example. All right, when you plug it into the wall and you're making a cake mix or something, you put all your ingredients in the bowl and then you just flick a switch and the beaters start turning very, very quickly. Okay, and that mixes up your cake stuff in, I don't know, like 30 seconds or a minute. Well, what that's doing, okay, the whole point of using that machine is so that you personally don't have to sit there with your arm, okay, moving like crazy and doing this yourself. It would probably take you longer to do it. Okay, so when we look at an electrical appliance, that appliance is doing work for us. In theory, it's making our lives easier. Okay? If something is boiling water or heating something up, okay, from room temperature or cold to super hot in a very short amount of time, it's going to use a lot of power to do that. Okay? Things like kettles, even though they're not used for very long, kettles, toasters, dryers, okay, hair dryers, all of these machines that heat things up, they use a lot of power. Because it takes a lot of power to go from regular temperature to super hot in a very short amount of time. So does that make a little bit more sense to you now?